Alright, so this question we're going to go through today is from the 2018 HSC physics paper, question 27. So the diagram shows a camera and a ruler set up to obtain projectile's motion, trajectory shown below. The entire trajectory is visible through a camera. Identify one of the errors in this setup and describe the effect of this error on the results. So to answer this question, firstly, you need to identify one of the errors, and describe the effect. So error, what's the error, and then what does that error do to the result? Now you can do it two ways, although there's actually a couple of errors you can look at. As given by this, it says errors, meaning by the question is expecting there are multiple errors that you could find, but question only asks for one, so we're only going to do one here. Now, if you actually have a look, that little meter ruler thing that's going to measure the whole range or displacement, that kind of stops here. So as you can see, that's not really the true path that the projectile takes. It actually starts from point P, so it's around about here, then it goes all the way down there. So that's one of the errors. Another of the errors that I did look into is actually the positioning of the camera. So the camera isn't directly at the center, so you can't really track the instantaneous velocity of that projectile as well, because that's main part you're trying to look at. But we're going to focus on the range one because that's quite an obvious one. So I'm going to format this error. So the error identified is position of the meter ruler. Okay, so why would the meter ruler be an issue? Okay, so the effect. Well, the thing is, so when it comes to the effect, what we actually know is as the ruler is placed in the incorrect position, you cannot obtain an accurate measurement of the projectile's distance, or in this case, horizontal displacement. Okay, so if I can't take an accurate measurement of the projectile's horizontal displacement, there are a couple of other things I can't analyze. I can't analyze the horizontal velocity, assuming that because the camera is also positioned in the wrong direction, in the wrong position, so that can have an effect too. So that's my error, and that's the effect of not having the ruler going in the whole position. So ruler needs to be placed in the position that tracks the whole journey or horizontal displacement of projectile. Okay, so there we go with that. Okay, B, we have an experiment set up based on described in part A, but conducted so that the data obtained was valid. The other thing is, not only is it not accurate because you're not measuring everything, but obviously it makes it invalid as well because that's not helping you find the answer, is it? So that's also an invalid experiment. Right, the image shows the trajectory of the ball. It goes like that. And we have the starting position drops down like that. And we have two graphs derived from that trajectory. We have the horizontal displacement and we have the vertical velocity. It says, using the graphs, describe the velocity and acceleration of the ball and quantitatively and qualitatively. So quantitative in words, quantitatively numbers. Okay, so let's have a look here. Okay, so if we do the qualitative analysis, it can just be, words or pointers that you find important. So we know that in this case, okay, and I'm just going to label this graph. The reason why I'm going to label it is usually when you label the graph for the examiners, it makes it more clear for them when you reference the abbreviations. Okay, maybe I'll just write it a bit further here. Aha, take that. Next one we have is the vertical velocity, so we'll just call that Vy. Okay, so quantitatively on graph Sx versus time, we have a constant gradient. So constant gradient okay, Sx versus Ty, we have a constant gradient, which implies we have a constant horizontal velocity. Okay, so constant velocity. Now, how can we prove this mathematically? Quantitative, and we'll also put the quantitative one over here. So the reason being is rise over run, so gradient is equal to Sx over t, which is also equal to Ux. So if we have a linear gradient implies we have a constant velocity there. Just remember, if it's a straight line, it means whatever the gradient value you get is going to be a constant value. If it's a curved line though, so say if the horizontal displacement was curved like that, then it implies that there was some form of acceleration. Okay? So there is that, or increasing value. Doesn't necessarily mean acceleration depending on, what you're looking at. Okay, so that does that, and that also means that the horizontal acceleration is equal to 0 as Ux is a constant value. Okay, next one we have is the vertical velocity. As you can see with the vertical velocity, it is again a decreasing linear sort of function. In this case, maybe I'll just write it out here. So quantitative or qualitative and quantitative. And this one would be for Uy and Ay. So uy is the velocity, as you can see, is increasing. So ui is increasing towards negative. So that would imply that it is falling. If we're assuming that, if we assume negative is going down, yeah? And if we have a look at this, the gradient of that graph is ui over t, or the change in ui over t. And so that would also equal to the acceleration. It's a linear function. Hence, ay is a constant value. So there is that. So that's how you go through those questions. I mean, it says qualitative, so that's, deriving equations and not just using words to describe it. If you want, though, you could even potentially, find the actual gradient value of the slope, or draw your own line of best fit, and then, calculate those values to show the values you were talking about, show that the horizontal velocity here is indeed constant, and to show that the uh, vertical acceleration is constant too. But that's purely up to you. I think that would be enough because you've already described it, you've already made comments about it, you've already showed formulas to match it. So I don't necessarily believe you would need to add or include numbers to it. But anyhow, that's how you do the question.